My name is Pavel Alvarado. I'm co-founder and CEO of Minero Inc. Today I'm going to talk about Minero Suite 1.0 or Identifier. Or Identifier is a step-by-step process of the ore control production activities. Here engineers can create their drill hole pattern design, transfer codified pattern information to a database, and load the assay information from laboratory back to Minero. Then engineers can perform estimations using ordinary kriging. After the estimation, engineers can create their optimal mining polygons using addition and reporting tools. Let's double click in the Minero icon to start. I'm going to open a project. This is the Marvin deposit. Let's start with the topography. We have here the surface. All this topography was created in Minero. Every 15 bench height. So let's go to pattern and see what we have here. We have procedure, we have production. I'm going to display on and off. So this is production and this is procedure. This pattern design was created inside the pit extraction shape, which is this area in this particular bench 930. Ore control is very granular, and then we have to focus in the production areas. This particular case, and we are in elevation 930. We have a pattern was created in Minero. In this case, a procedure next to the final pit or the pit limit, and a production pattern next to it. In order to create pattern, we can use Minero edit tools to create patterns. We can, once we finalize the pattern creation, we can either send this information to the database, or we can save these files in flat file format. It's a user decision to be saved in a particular way. So in this particular case, for the purpose of this exercise, we gather, let's say we gather all the information of the pattern, and we got this information, and let's put it in the table view in this side. That way I can visualize what I have. Let's go to production assay. Production assay, we have pattern coordinates XYZ, the ID, gold grade, copper grade. Those are and this particular pattern has 134 points, and we are storing gold and copper. The colors are these values are actually in render property are colored properly, and the cutoffs we define it here from 0 to 0.2 is blue, from 0.2 to 0.4 is cyan, 0.4 to 0.6 green, and so and so. So we also have information from our short-term planning. This comes from the short-term planning department. So I will off now for a minute the production and procedure data. We will look at the STP block model. The STP block model basically is the information from that comes from LTP. The bottom line is we will use this short-term planning model will give us an idea how it looks like when we want to start working in ore control. We want to see the overall picture of how it looks like the deposit. So this is the short-term planning model, and based on that we will have an idea how the deposit looks like. Okay, so since we already have a drill plan and we decide, okay, we want to start working in a specific area. In this particular case, in the red area, we have our drill plan, and our blast holes are inside that red area. Okay, so we have now the information from laboratory. We have the information completed from the assay, from gold assay information from laboratory. So then we can create our production or control production block model. This STP always we can use as a reference, but this is what we're going to build. We can build that ore control production block model using ore control estimation parameters, applications, in this case Krieg, and with this pattern information we can get actually the production information. Okay, so I use the estimation parameters and I created the ore control, and this is how it looks like our ore control production block model. This is basically, we can accomplish this in ore control, and there are a number of steps, but this is something that we can do in Minero in this ore identifier model. Now have the pattern procedure and production model, in this case data, and we will focus on the block ore control production block model. So this is what we can get using Minero applications. So now this is how it looks like the deposit. We can get we can go very granular on the block by block level, and also annotate what the routings for these particular blocks. These routings were predefined here in Minero using again compute route or compute variable that also can be used to and we can classify our deposit, our block by block on the block by block level, our deposit, and visualize how this deposit looks like. Like I said, this block model or control block model is smaller than the STP block model. The STP block model has a distance of 15 by 15 by 15. Your control model is 5 by 5 by 15. All this information we can always see here in info and table view info. Here is the ore control production model, and the STP and model also we can visualize the information right there. Okay, so now that we gather all this information, what we can do is we can create the mining polygons. Actually, before the mining polygons, we can contour this. We can contour using again Minero tools. We can contour our block model, and it's kind of a guideline to start building our polygons. In this particular case, I decided to build 2 polygons, mining polygons. I'm gonna put it on. So I have here 2 mining polygons, and something important here is to report what we have in those 2 mining polygons. For instance, what we have in cyan is oxide low leach, and in blue actually is waste material, and in green here we have oxide general leach. Okay, we will. It's important to report, and this is probably the something that will make us will help us to make the decision what material gonna go to what destination, and always we will be able to modify these polygons, edit them, and create our final mining polygon that we will be sending to the right destination. So I'll need to select the polygon object, mining polygon, and have to select the block model, Marvin block model control production, and a density variable in this case. Using this report, we can just run, and we will be able to get information, very detailed information, mine polygon 1, this polygon here, average gold is located actually in bench 930, gold grade 0.24 weighted average. We have the classification for ore type for waste material, 18% oxide general leach, non-material, and oxide low leach, 82% is in here. If we want to modify, we can do that, and then we can run again the report, and we will get different values. This is something that will help us. This dilution report will help us make the right decisions on the field. Mining polygon 2, the small polygon in the right inside, we have oxide general leach is 51%, and oxide low leach is 49%. Again, these reports will help us make important decisions in order to decide, okay, it's going to go to the leach pad anyway, this for instance polygon number 2, so no matter if it's if we have more general leach and low leach, we still will be sending to the same destination. This is this is an example of some of the decisions that engineers would like to make based on the facts that they have in front of them in the grade tonnage reports. So once again, we accomplished another activity in Minero. This time we were able to follow through the overall ore control process in a matter of minutes. Don't hesitate to visit us at our webpage, www.mineromining.com. We will be happy to answer your questions and suggestions. In name of the Minero team, I have to thank you for your time.